Hello everyone, welcome to 1000 Math 7. This is the exercise 1.5 okay of the chapter sets, and today we'll be solving this exercise and we'll see how we can solve this. But before you watch this video, please make sure to watch the lecture video before this exercise, uh, complement of a set, okay, to know what is a complement or how to find the complement of a set, or when exactly we need to think of a universal set to find the complement of a set. Okay, so here the first question is, let U, okay, this is the universal set. 1 2 3 4 5 6 7 8 9 are the elements in this set. There is a set A, which is 1 2 3 4 are the elements. There is a set B, which has 2 4 6 8 as the elements, and there is a set C, which is 3 4 5 6 as the elements. Now each of the set has been given in the roster form, right? And it says find A dash, means A complement, find B complement, A union C complement, A union B complement, A complement complement, this is double complementation, and B minus C complement. Okay, so let's try to solve the first one. What is A complement? Now A complement is a what? It's a set, and it's a collection of some objects that is not present in the set A but is present in the universal set when we compare the set A with the universal set. So here A is a set, U is a universal set. So what will be A dash? Elements that is not present in the set A compared to the universal set. So set A has 1 2 3 4. So the A dash or the complement of A will have what? The rest of the elements, that is 5 6 7 8 and 9. Okay, this is A complement. So when you do from the theory, okay, if you have watched the theory, you must have got to know that A union, A complement will give you what? The universal set. Like if you think in terms of Venn diagrams, let's say this is the universal set and there is a set A. Okay, so this inside part is A and the outside part is what? The outside part of the circle is A dash. So when you combine this circular region and also combine the A dash, it will give you the complete what? Universal set. So this is the theory that we have learned. So A dash is this. Now let's try to find number 2, B dash. So B dash will be what? Set of all the elements that is not present in the set B when compared to the set U. So it will be what? 1, not 2, then 3, not 4, then 5, not 6, and 7, not 8 and 9. Okay, apart from the elements that is present in the set B. Now we need to do the third one. Okay, A union C dash. So first we'll do A union C. Okay, so what is A union C? These two sets combined, right? Union means to unite, to combine. So it will be 1 2, then 3, right, and then 4. So these are the elements of the first set, A. Now let's see the elements present in the second set, 3 4 5 6. So I have 3 4 and I'll write 5 and 6. Okay, now this is A union C and I need to find the complement of this. Now whenever I need to find the complement, I'll look at the universal set and I'll try to check which of the elements are not present in this set. Okay, so the complement will be what? 1 2 3 4 5 6. I cannot include the first 6. It will be just 7 8 and 9. So this is the exact answer of A union C dash. Now the next one is number 4, is A union B dash. So let's try to find A union B first, okay, and then we'll do the complement. So what is A union B? It will be what? This and this set combined. So it will be what? 1 2 3 4. Okay, the first 4 elements, the 4 elements of this set A I have written. Now 2 I have a 2, 4 I have a 4, 6 I don't have a 6, and I don't have a 8. So this is A union B and I need to find the complement of this. So what will be the complement? It will be 1 2 3 4 will not be included. 5 I'll have to include when compared to the universal set. Then I'll not include 6. 7 I'll include. 8 I'll not include, and then I'll include 9. So this is A union B complement. Okay, now number 5 is A complement complement. Now this is double complementation. Okay, you complement a set once and do the complement once again, it will give you the same set back. That is, the answer will be A for sure. Let's try to check it. Okay, so here what is the set A? This one, right? I need to find A complement once and then complement once again. So let's do complement one time first. So what is A complement? This one, right? We have found it. So this is 5, 6, 7, 8, 9. Right? This is A complement one time. Now if we do it two times, this one, okay, then it will be what? Now this is a set and I need to find the complement of this. Think in this way, okay, and try to compare with the universal set. So which are the elements that is not present in this set? It is 1, 2, 3 and 4. So this is the complement, okay. And now if you look at this set, this is what? Basically the set A itself. 1, 2, 3, 4 are the elements of this set. 1, 2, 3, 4 are also the elements of this set. Means this is the set A, okay. Now the next one is, so I've proved it, okay, A dash dash or A complement complement or double complementation is the set itself, okay. And now the last one is B minus C dash. So let's try to find B minus C first. So what is B minus C exactly? B minus C is a set or difference of sets, as we have learned in the previous lecture. So B minus C is a set which has all the elements that purely belongs to the set B and not to the set C. Okay, so what will be B minus C? Try to check between these two sets which of the elements purely belongs to the set B. 2, yes, 2 is only present in the set B, so I'll include 2. 4 is present here also, so I'll not include 4. 6 is present here and here also, so I'll not include 6. 8 is present only in the set B, means 8 purely belongs to the set B, so I'll include 8. 8 is not present here. So this is B minus C and I need to find the complement. Now whenever I talk about complement, look at the universal set, okay. So the universal set is this. So what will be the complement? Elements which are not present in this set compared to the universal set. So it will be 1, I'll not include 2, 3, 4, 5, 6, 7, I'll not include 8 and finally 9. So compared to this set. So this is the exact answer for B minus C complement. So this is question number 1, okay. Now the next question is, if U is A, B, C, D, E, F, G, H, okay, this is the universal set that has been given to you. It says find the complement of the following sets. I need to find A complement, B complement, C complement and D complement, okay. So A is a set that has 3 elements in it. So what will be A complement? A complement is A dash. It will be a set of all the elements that is not present in the set A when compared to this set. So A has A, B and C. So A does not have what? D, E, F, G and H when I look or when I compare with the universal set, right? So I'll write D, E, F, G and H. Okay, so this is A complement. What will be B complement? Elements that is not present here, means what? I'll check it with this set. Here there is no A, so I'll include a A. Here there is no B, I'll include a B. I'll include a C. D is there, so I'll not include D. E, F, G is there, I'll include the last one, that is H. Okay, so this is B complement. C complement will be what? A is there, okay, A, C, E, G is there. A, C, E and G is there. So what is not there? B, D, F and H. B, D, F and H. Okay, and what will be D complement? F, G, H and A are there. So A, F, G, H are there. So what is not there? B, C, D, E and B, C, D, E. Okay, B, C, D and E are not there. So this is D complement. Okay, so I hope this is clear to all of you. Now let's move on to the next question here. Here it says this, taking the set of natural numbers as a universal set, means here the universal set is a set of natural numbers, which is 1, 2, 3, 4, 5 and as long as you want to write. This is the universal set for all these questions, okay, because whenever we need to find a complement, we need a universal set. So this is a universal set that has been given to you. So it says taking the set of natural numbers as a universal set, write down the complement of the following sets. Okay, these are the sets. All of them has been given in the set builder form. So this is a set of what? X such that X is an even natural number. Now what is the complement of this? The complement will be what? I'll try to write it in the set builder form itself. Okay, so the complement of this is what? This is a set of all the even numbers in the set of natural numbers. Now you know that in the set of natural numbers you have two things, right? Here you have odd numbers as well as even numbers. So the complement of this will be what? X such that X is an odd natural number. Odd natural number, simple, right? Because this set is the set of even numbers, So the complement means when you think in this way, what is not present in this set when you compare with the universal set? It's the odd numbers that is not present. Okay. Now the next one is x such that x is an odd natural number. So this is a set of all the odd numbers. So what will be the complement? Set of all the even numbers. Simple. X such that x is an even natural number. Okay. Now x such that x is a positive multiple of 3. Now positive multiple of 3. Try to think what will be the elements in this set. Multiples of 3. Positive. Okay. So the first multiple of 3 is 3 1 time 3 itself. Then 3 2 times 6. Then 9. 3 3 times 3 4 times is 12 and so on. It will go on. So these are the elements of this set. Okay. So what will be the elements of the complement? It will be what? Complement will be what? Which is not a multiple of 3, right? Means either you can write it in the roster form as 1 2, then I'll not include 3 4 5, I'll not include 6, then 7 8, I'll not include 9, and so on. It will go on. And if you write it in the set builder form, okay, it will be 1 x such that x is not a positive multiple of 3. Okay, you can write it in this way: x such that x is not a positive multiple, okay, of 3. This will be your answer. Now here says x such that x is a prime number. So this is a collection of or set of all the prime numbers. So what will be the complement? X such that x is not a prime number, not a prime number. Okay, or you can say x such that x is a composite number, composite number. Okay, prime numbers and composite numbers are like all these numbers, all the numbers present in the universal set will be divided into two types. One is the composite numbers and one is the prime numbers. Okay, now you can either write this one or this one, both are correct. Okay, now the next one is x such that x is a natural number divisible by 3 and 5, 3 as well as by 5, and see, and so 3 as well as by 5. So this set is a collection of such numbers. Okay, each of the number is divisible by 3 as well as by 5. So the LCM of 3 and 5 is what? If you know how to find LCM, okay, 3 comma 5, so it's not divisible by any of those. So I'll just do 3 into 5, that is 15. The 15 is the smallest number that is divisible by 3 as well as by 5, right? So the elements of this set are what? 15, then you'll have 30, then you'll have 45, then you'll have 60, and it will go on. So these are all the numbers that is divisible by 3 as well as by 5. So if you want to write the complement of this set when compared to this set, it will be what? X such that x is a natural number not divisible by 3 and by 5. Simple, just include a not here, not divisible by 3 and 5. Okay, now x such that x is a perfect square, it says. So or in this question in the roster form, you can write it in this way. Okay, 1 2 3 4 until 14, 15 will not be included, then you will use 16 17 until 29, and it will go on. 30 will not be included, in that way. Okay, now x such that x is a perfect square. What is a perfect square? If you think 4 is a perfect square, see, 2 square, 9 is a perfect square, 3 square it is, then 16 is a perfect square, which is 4 square, 1 is also a perfect square because it's 1 square. So in that way, x such that x is a perfect square. So in this question, all the elements that will be present, okay, will be perfect square. So the elements of this set are what? 1, then 4, then 9, then 16, then 25, then 36, and so on. It will go on. So the complement of this set will be what? Elements that are not perfect square. Okay, so you can simply write complement of this will be what? X such that x is not a perfect square. Okay, not a perfect square, SQ I've written. Now x is that x is a perfect cube, means here the collection of all the elements will, like each of the element will be a perfect cube. What is a perfect cube? 1 is a perfect cube because 1 cube will give you 1. 8 is a perfect cube because 2 cube will give you 8. Okay, 9 is 20 27 is a perfect cube because 3 cube is 27. Then 64 is a perfect cube, okay, because 4 cube is 64. So cubes, you'll think, so that when you do cube root, okay, cube root of 64 will give you what? 4, perfect cube, okay. Root will be removed. This was called as perfect square because square root, when you do square root, this was cube root, okay. So square root of, let's say, 16, so it will give you exactly 4. So this is perfect square, this is perfect cube in that way. So here the complement of this set will be what? X such that X is not a perfect cube. Simple, okay. Now the next one is X such that X plus 5 is equal to 8. So when you try to solve this equation, X such that X plus 5 is equal to 8, it means elements of this set are what? You need to solve this equation. X plus 5 is equal to 8. So do 5 on the other side, X is equal to 8 minus 5, because plus 5 is here, so it will become minus 5. So X is equal to 3. So this is a set which has just one element, 3. So what will be the complement of this? It will be what? All the other elements, means 1, 2, not 3, then 4, 5, 6 and so on. This is the complement, or in the set builder form you can write it in this way. X such that X belongs to natural numbers, because the universal set is the natural numbers, okay, and X is not equal to 3. Just then X is not 3 and rest all the natural numbers. So this is what. Now the next one is X such that 2x plus 5 is equal to 9. Okay, this is once again an equation. Let's solve this equation first. 2x plus 5. Whenever you get an equation, try to solve it, okay, and find the value of X. So 2x is equal to 9 minus 5 will give you what? 4. Then X is equal to 2. So here the only element of this set is 2. Okay, so the complement of this will be what? 1, not 2, then 3, 4, 5, 6 and so on. And in the set builder form, how can you write it? X such that X belongs to natural numbers and X is not equal to 2. Simple. Okay, it just cannot be 2. Complement means all the other elements that is present in the universal set when compared to this set. Now this set has just one element, 2. So which of the elements are not present in this set? This is 1, 3, 4, 6, 5, 6 and so on. Okay. Now here it says X such that X is greater than or equal to 7. Okay, means this is a set in which the elements are what? Greater than or equal to 7. So I'll include 7, and greater than 7 is 8, then 9 and so on. So what will be the complement of this? That is less than or equal to 7, means elements that is not present in this set when compared to the universal set. So I have all the numbers from 6. I have all the numbers from this point here, from 7. So this is what I don't have in this set. So that will be the complement set. Okay, so it will be what? 1, 2, 3, 4, 5 and 6. Or in the set builder form, what can you write? X such that X is less than 7, which will give you what? And also you need to include, okay, this is the correct way to write. X such that X belongs to natural numbers, means each of the X should be a natural number, and what? X should be less than 7 also, so that you get this exact answer. Okay, now here it says X such that X belongs to natural numbers and 2x plus 1 is greater than 10. Okay, this is the equation once again. 2x plus 1 is greater than 10. Try to solve this. 2x, take the 1 on the other side, will give you a 10 minus 1 because it's plus 1 here, so it will give you 9. So x is greater than 9 by 2. 9 by 2 is what? 4.5. Means x is greater than 4.5. Now if you try to recall the number line, okay, there is a 0, there are all the negative numbers on the left hand side, all the positive numbers on the right hand side, right? 4, 5, 6 and so on. So this is the number line. Here it says x is greater than 4.5. 4.5 is somewhere in this point, 4.5, between 4 and 5. Okay, now if you see here, x must be greater than 4.5 and x must be also a natural number. So what is the exact elements of this set? The first natural number greater than 4.5 is 5, then I have 6, then I have 7 and it will go on. So these are the elements of this set. And what will be the complement of this set? All the elements that is not present in this set when compared to the universal set, right? So it will be simply 1, 2, 3 and 4. Okay, or in the set builder form, what can you write? X such that x belongs to natural numbers and x is what? Less than 5. X is less than 5, or you can say X is less than or equal to 4 also. It's the same thing, okay? Because equal to means 4 will be included, and if you don't write this equal, then write 5 here, so that it's less than 5 means 4 is included and 5 is not included, okay? Now the next question is, if U is 1 2 3 4 5 6 7 8 9, okay, this is the universal set, and there is a set A, there is a set B, okay? Set A has 4 elements, set B also has 4 elements, different elements though, okay? 2 is common, 4 is not common, 3 is not common, 6 is not common, 8 is also not common. Only 2 is common here, okay, between A and B. Now it says verify that A union B dash is equal to this. Now these two laws, I think these are the De Morgan's law, okay, De Morgan's law. I have shown you in the lecture video the proof of this, okay, by using Venn diagrams. Now let's try to show this. Here the first question is, show that this is equal to this. So let's take the left hand side, or whatever our answer is for the left hand side, we'll take the right hand side and we'll check if both of them are same or not. So for the first one, let's take the left hand side. Left hand side is what? A union B dash. So let's first do A union B. A and B together. It will be what? 2, then 3, okay, then 4, then 5, then 6, 7 and 8. Okay, I'll include all the elements that is present in set A and set B. Set A has 2 4 6 8, 2 4 6 8 is present here. Set B has 2 3 5 7, 2 3 5 and 7. So all of them are included. I need to find the complement of this. So whenever I need to find complement, I'll look at the universal set. Now I'll think in this way: which elements are not present in this set when compared to the universal set? Is what? I don't have a 1, I have a 2, 3, 4, 5, 6, 7, 8, and I don't have a 9. So this is the complement or exact answer of A union B dash. Now let's take the right hand side. Right hand side is what? A dash, A intersection B dash. Okay, A dash, A intersection B dash. So let's find A dash first. A dash is what? 2, 4, 6, 8. Apart from 2, 4, 6, 8. Okay, so it will be 1, 3, 5, 7, and 9. Right? When you compare with the universal set, okay, then intersection, this intersection, then try to find B dash. What will be B dash? It will be 1, then 2 3 will not be included, then 4 5 will not be included, 6 7 will not be included, then 8 and 9, right? Now intersection of this set and this set, which are the common elements? Intersection means what? Intersection of two sets means the set of the common elements present in both the sets, okay? Which are the common elements? 1 is common, right, present in both the sets. 3 is not common, 3 is not here. 5 is not here, not common. 7 is not here, not common. 9 is present here and here also. So the common elements are what? 1 and 9. Now check. When you took the left hand side, you got the set to be 1 and 9. And when you took the right hand side, you once again got 1 and 9. Means left hand side is equal to what? Right hand side, right? So what can I say? That this is equal to this, hence proved. Okay, this is equal to this. Now let's take the second one. Let's take the left hand side here, okay? A intersection B dash. So let's do first A intersection B. Do part by part, okay? First do A intersection B, then do the complement. Take help of the universal set. So what is A intersection B? Common element 2, 4, 6, 8. 2 is common between these two sets and nothing else is common, right? So just 2. Then I need to do complement. So what is the complement of this set? When compared to this, it will be what? 1, 3, 4, 5, 6, 7, 8 and 9. Apart from 2, all the other elements that is present in the universal set, because 2 is present in A intersection B and I am doing complement. Okay, so this is A intersection B complement. Now let's take the right hand side. Let's check if it is the same answer or not. Okay, the right hand side is what? A dash union B dash. A dash union B dash. So I found A dash is this, right? 1, 3, 5, 7, 9. And I'll do union, this union, okay, and then B dash is what? 1, 4, 6, 8 and 9. Now combine these two sets, it says union, right? So 1, okay, 1 will be included, then 2 is not there, okay, 2 will not be included, 3 is there, 4 is there, 5 is there, 6 is there, 7 is here, 8 is here and 9 is here. So all the elements are included. Now check. Here all the elements except for 2. Here also all the elements except for 2. So both the sets are same. That means left hand side is equal to what? Right hand side. That means I can say A intersection B dash is equal to A dash union B dash. Hence proof. Okay. Now It says draw appropriate Venn diagram for each of the following. Now look carefully. For the first one, it says A union B and dash. So let's say we'll do first do A union B. So there is a set A and there is a set B. Let's say this is A and this is B. Okay. So A union B. I've told you that there are four diagrams. Okay, in the lecture video. For union, there can be four possible diagrams. One can be this one, when the set A and set B has something in common. Okay, not everything is common. And then when the set A and set B, one of the set is a proper subset of the other, means let's say A is a proper subset of the set B, means all the elements that is present in set A is also present in set B and B has something extra. In that case, union will have this Venn diagram. Okay, then if the two sets that we are uniting or we are finding the union of, they are equal. Okay, if set A and set B are equal, then the diagram for union will be two circles on top of each other, two circles of the same size, because the both sets are equal. And if the two sets have no elements in common, then it will be two circles just nearby each other, but the circles will not touch each other, and these are also called as disjoint sets. Okay, now let's take this one as a standard. Okay, I've told you in the lecture video. So A union B will be what? A and B combined. Okay, this is A and this is B. Now it says A union B we have done, then we'll have to do the complement, means I'll have to take the universal set also. Okay, now this is the universal set. So A union B is this whole thing, right? Let me take the pencil here. So what is A union B? All the region that is present in A and B, right? This is the region. So what is the complement? Complement means apart from A and B. So it will be what? The outside region, right? This is the region leaving behind A and B. So in this way you need to draw. Okay, the pencil part is what? A union B. And what is A union B complement? It will be the region outside of A and B union. Okay, so this is the first. The second one, A dash intersection B dash. Now look at this carefully. A dash. So A dash will be what? First draw a A, and since I need to find A complement, so I'll draw the universal set around it. Okay, so this is, if this is A, then what is A dash? Outside of A. Okay, the outside part. Okay, this is A dash, all the part that I have shaded. This is U. Now B dash is what? I'll draw the set universal set, and there is a set B, let's say here. So B dash is what? Like this. See the pattern of lines that I'm drawing. Okay, so that I need to, so that I can show the exact answer to all of you and you get to understand. For B, I have written the shading is done in vertical way, and in this A complement I've done the shading in horizontal way. Okay, now look at this. You need to do intersection. Intersection means the common region, right? What is the common region between this and this? So you need to combine both and check. Okay, do the combination. There is A. Okay, so when you do A complement, means all the region that is outside of A, right? This is the way you will shade the region. Okay, all the region that is outside A, this is A. Now when you draw B, okay, this is B, then all the region B complement means all the region outside B. So I'll include all the region that is outside B. I'll not just cut B. So which is the common part? All the part that has been intersected. Okay, the region of A is not included, the region of B is not included. See, there are just single lines here. Whatever line is inside A, this part is untouched. Okay, and this part also has just single lines. Double lines are, the crisscrossing lines are on the outside region. So these two sets are what? Same. This is the De Morgan's law, that A union B, okay, A union B complement will give you A complement, and union will become intersection B complement. So this is the way. Okay, now the next one is A intersection B complement. So what is A intersection B? So when you have a universal set and when you do A and B are together, this part is the common part or the A intersection B part. So what is A intersection B complement, leaving behind this part every other part, means all the region that is present here. Okay, so just leave this region. Okay, this region is untouched, and outside of this region is the complement. So this is the region. Okay, this is the universal set, and the all the pencil region is what? The A intersection B complement. Now try to do this. A complement union B complement. So when you do A complement, you get this, right? And when you do B complement, you get this. Now when you combine both of them, okay, union C, so you will combine both of them in this way. So A complement means all the region that is outside of A and all the region that is outside of B. So just leaving behind this common region, okay, in the same way. If this is A, then all the region outside A. Let me shade it out for you. Okay, this is the region that is outside A, right? This is all that is outside A. And if this is B, all the region outside B, okay. Now, if you look carefully, since I need to do union, so I'll not go for the single lines. I'll also go for the single lines, I'm sorry, because in case of intersection, I need to find the common part. So in this case, we don't include the single lines, but here we'll also include the single lines also. So just this is the region that has been untouched, and apart from that, everything is touched. And this is also same here. So this is a De Morgan's law, that A intersection B complement is equal to what? A complement union B complement. See, A intersection B complement was just this region was left out. Everything else is there. Here also, just this region is left out. Everything else is same. In this case, A union B complement, this A and B was left out and everything else was included. And if you try to check for this A and B was left out, and this middle region was also left out, okay, and everything else is included because everything else has been crisscrossed or intersected. Okay, so this is the proof of De Morgan's law that we have also done in the theory video. Now let's look at the next question here. Here it says, let U be the set of all triangles in a plane. Okay, if A is a set of all triangles with at least one angle different from 60 degree. Okay, now U is a set of all triangles. Okay, U is the what? Set of all triangles in a plane. All triangles means what? It can be equilateral triangle, it can be isosceles triangle, it can be acute angle triangle, it can be a right angle triangle, any type of triangle. And there is a set A, which is what? Set of all the triangles with at least one angle different from 60 degree. Triangle means what? There will be three angles in it, and if all the three angles are 60 degree each, then it is an equilateral triangle. Here it says at least one angle is different from 60 degree, means one of the angle is not 60 degree. Okay, so A is what? A is a collection of all the triangles. Okay, all the triangles apart from what? Equilateral triangle. Equilateral triangle, because if it's if A, the collection, the set A also includes the equilateral triangle, then this condition would not have been there. Okay, here it says A is a set of triangles with at least one angle different from 60 degree. One angle is not 60 degree. So what will be A complement? Set of all equilateral triangles, simply because U has all the different type of triangles and A has all the different type of triangles, but it does not have those triangles in which all the angles are 60 degree, because it says at least one angle is not 60 degree. So what will be A complement? Set of all equilateral triangles. Okay, equilateral triangles, or what can I say? Set of all triangles in which all the angles are 60 degree. Okay, means equilateral triangles, the same thing. Now fill in the blanks to make each of the following a true statement. Okay, A union A dash. Now think in this way, think in terms of Venn diagram. Okay, there is a set A and this is U. So this inside part is A and the outside part is what? A dash. So this part and the outside part combined together will give you what? The universal set itself, right? That is U. Okay, then phi dash means what? Phi is a set which has no elements. So phi complement will give you all the elements. That is the universal set. We have seen this in the properties. Okay, so phi dash means what? The universal set. Okay, and it says intersection A. If this is a set A, okay, then what is the intersection of this? This means what? U. This equation can be converted in this way. Phi dash is what? The universal set. Intersection the set A. So what is the common part between U and A? The A part itself, right? So it will give you A. Then A intersection A dash. So this is A, inside region is A, outside region is what? A dash. Is there anything common between what is present inside and what is present outside? No, nothing is common. So this will be phi. And U dash is what? U dash means complement of the universal set is what? Phi. Okay. So this can be rewritten as phi instead of U dash in intersection A. Now check, phi is a set that has no elements in it, means null set. So is there anything common between a null set and a set A? No, nothing is common. So it will be what? Phi. Once again, that is a null set once again, because null set has no elements. So how can it be common to some of the elements that is present in the set A? So this is the exercise 1.5, and thank you so much for watching this solution video. I hope that each of you got to know how to solve the questions, and if you have any questions, do make sure to post it in the comment section below. Thank you.